My fellow Americans, only geothermal energy has the potential to diminish the potential for potential global warming. This is the potential of the potentiality. It could cause what we could consider global winter. What would you do if it was winter all the time? Just what could you do?
Well, us blockheads, we would probably spend some time out there taking advantage of all that snow. Let's do some light skiing, yeah.
Now and then I think of when we were together, like when you said you felt so happy you could die. I told myself that you were right for me, but felt so lonely in your company. But that was love and it's an ache I still remember. Resignation to the end, always the end. So when we found we could not make sense, well, you said that we would still be friends. But I'll admit that I was glad that it was over.
We'll have to catch up with those guys later, huh? Nice.
Alright, so we're going to give a quick rundown of the mechanical.
Well, this is not working today. Let's see what we got.
Because the Earth absorbs and stores much of the energy it receives from the sun as heat, underground temperatures remain constant at a point between 42 and 80 degrees Fahrenheit year-round, depending on where you are in the United States. A geo-exchange system
Must be a busy afternoon here at University of Montana. Some buffering going on.
Can use this energy source to economically heat and cool almost any kind of building, heat water, provide refrigeration, and perform many other kinds of applications. A geo-exchange system is made up of 3 components: a heat pump, usually located inside the building where it's protected from the environment and vandalism; an underground heat exchanger to act as a heat sink to store energy in the earth when cooling, and to extract energy from the earth when heating; and a distribution system such as air ducts or hydronic radiant floor tubing to provide comfort control for the building space.
I'm a fan of the hydronics.
The 2 types of heat exchangers commonly used are open loop and closed loop. A closed loop system uses a system of continuous underground pipe loops in which both ends of the pipe system are connected to the heat pump, thereby forming a sealed closed loop. Water, or a mixture of water and environmentally friendly antifreeze, circulates through the loop to transfer heat between the heat pump and the earth. In some installations, the pipes of a closed-loop system can be placed in a horizontal trench dug below the frost line. The number of pipes in each trench and the number of trenches needed will vary depending on the size of the geo-exchange system being installed and the type of soil found in the area. To minimize trenching, slinky coils, spring-like coils of polyethylene pipe, can often be used to increase the pipe surface area and thus the heat exchange per foot of trench. Another way to increase the heat exchange rate of a closed-loop system is to take advantage of the naturally higher heat transfer capability of water over soil or rock. If a stream, river, or pond of sufficient size is available, coils of heat exchanger pipe can be installed on or near the bottom to form a pond loop system. In locations where space is limited or a large heat exchanger is required, the pipes of a closed-loop geo-exchange system can be installed vertically in wells drilled into the earth. As with the horizontal and pond loop systems, the number of loops and the depth of the wells needed in a vertical closed-loop system are determined by the size of the building, system demands, the ground temperature, and other variables. Since it's not necessary for the heat exchanger to be connected to the rest of the system above ground, whichever type is installed can be placed within existing landscaping, under sidewalks, driveways, and parking lots, or even beneath the building itself. In an open-loop system, on the other hand, groundwater from an aquifer is pumped through one well and passes through the heat pump where heat is added to or extracted from it. The water is then discharged back to an aquifer or harnessed for other water management uses. Because the system's water supply and discharge are not connected underground, the loop is open. To learn more,
It's your basic geo-exchange. All right, let's let Durban Geothermal now, let them show us the finer aspects of geothermal loop header tie-in. Now, the header is where all the pipes come together, and then you have one pipe that goes into your heat pump or into the house. Let's take a look at this. It's a good short video here. Saw the guy drilling the hole in the cement there. That's a spendy proposition. It doesn't take that long, but costs you a fair amount of money to have those guys come out and do it. if you just put in, if you are pre-construction and you're planning, you can just put in conduit, a cheap 4-inch or 2-inch white plastic, Schedule 40, and you just place it in the forms and just vibrate around that so that you don't have any cavities in the or openings in the concrete, especially on the underside of the culvert or conduit. Could be a problem. You see where you dug up some infrastructure there? You can see the pipes laying out. Some of these irrigation systems is going to have to be repaired. So it looks like some black polyethylene with welded connections here, and they're maybe doing a 1-inch header with 3/4 inch loops. Definitely welded. That or a PEX connection, expanded, then heated with memory, polyethylene memory pipe. This that way, when you get expansion and contraction underground, you don't loosen up your clamps. If you try to use just a standard stainless steel clamp, you're going to have some problems. There's your grouting, huh? Grouting to ensure contact for conductivity so you can harvest earth heat or lose house heat. This is a time lapse, so that the actual time involved here, there'd be I bet you there's $600 if not $1,000 worth of backhoe time in that. Thanks, guys. Urban Geothermal. Check out that website. There's a peek at your earth loop header. Like I say here, this is all available to you to review at your leisure. In the central column of our course, topic 7. And the current topic, by the way, is highlighted. See topic 6 here that doesn't have the blue highlighting. So we've got topic 7 is our current topic. Hey, let's take a look at the earth loop slinky.
Slinky loop, but we're first of all going to take a look at the board that we have here. And this board is constructed out of a 4x8 sheet of plywood with two 2x4s screwed through from the bottom. The distance is 3 feet from the inside edges of the two 2x4s, and starting from the discharge end of the board, we lay off marks 18 inches. And these 18-inch marks are the spacings on the loops for an earth loop. You will notice the small divisions in the middle. These smaller divisions are used when we're constructing a pond loop slinky, and we use a 4-inch pitch instead of an 18-inch pitch. So this board is just built very basically, set on a pair of sawhorses, very portable. So the board is the first thing that you're going to need to get set up. The coil of loop pipe. This coil of loop pipe is we've mounted it on a rotating table. So that it's easy to turn. That's not necessary. You can turn it laying on the ground, but I want you to note that we have laid it on the table so that the coil, this outside ring is up, and it spins counterclockwise as I look down from the top. First thing I want you to note is that there's 2 sets of bandings. We have the banding of the whole spool, and then the banding of the half spool. So the first 400 feet are single banded, the inside 400 feet are double banded at this point. First thing we're going to do is we're going to cut the outside bands. I want you to note that the pipe is labeled 00800. That's the 800 foot mark. Be sure and keep the cap on. And then if I come back 2 feet, I'll find 00798. And 2 feet farther back, I'll find the next number of 00796. Every 2 feet. And then of course at the end. So we're going to want to watch these foot marks as we're building the slinky loop. We already have some loose coils. So at this point in time, we'll just take these coils and we just slide them up on the slinky board. Since this is going to be a earth loop slinky, we're going to take the first 15 feet and lay it on the ground. We're not going to do anything with it. So there is 776. So I'm right here. There's my first 15 feet. And then we basically come right up to that edge, lay that one in, bring this one to this 18-inch mark, the next loop. Notice how I had to resize the circle so that I was 3 feet. Now that helps us bring this next one in place, and this one has to come down to here. So that means I have to supply some more pipe. The important thing is to take a spinner like this and an earth loop tie wire like this, and any place that we see a cross, we put the wire in, bring the two loops together. We will hook the spinner in it and basically spin it down. As you see it moving, or if it shifts a little bit, try to make your adjustment. Quite frequently we'll put two men on this side of the table and one man on the other side of the table because there's just about twice as many of them to do. So we're basically twisting the sides. Now, this point right here we will not put a twister on. And the reason we will not put a twister here is because if you want to roll this slinky up in a roll, these pieces need to be able to flex. If these pieces can't flex, it'll be very difficult to roll this slinky into a roll to store it. If you tied these together and laid the slinky out flat, left it flat, it won't hurt a thing. But trying to roll it up and store it, you do not want these tied. So, at this point, Dan and I will finish tying up this section, and then we'll bring that section off the board and start and show you how to continue. Alright, so at this point in time, one person feeds the pipe from the back, and one person pulls this off the board. I'd like you to really note what Dan was doing back there. The coils, because we can rotate the coil and compensate for any movement that we've had, we just lift the coils up and they slide right on the table. And so what we're really doing is we're just doing this and sliding it right on the table. We don't want to have to flip or twist. Just uncoil the roll as the pipe starts to tighten up. Okay, let's take and finish slipping this in here. Now you'll notice that Dan and I are being a little fussy here. It's not critical that these are perfect. It's more uniform, but it isn't critical in the operation of the slinky that these are perfect. Once we've done that, we just go back to work. What we've been doing here is just continued until we get the entire 800-foot spool made up in this slinky format like I have here in my hand. You keep sliding it ahead each time, doing 4 more circles. We will not cut that center band until we get to that point. However, I said something earlier about the numbers on the pipe. Remember, a earth loop slinky made out of an 800-foot spool is approximately 95 feet long. So that means I need to have 95 plus 15 if my first header was 15 feet. So I need 110 feet of pipe left to get back to that end that I don't slinky. So as you're building your slinky, really be careful and watch that length of pipe as you're getting towards the end so you don't have to undo. If you overshoot, big deal, just cut a few circles off. It's a little over 9 feet per circle, so that's pretty easy to calculate. And that's an earth loop slinky. Just keep it going.
Thanks, guys. Very informative. Yeah.